So silver has a work function of 4.7 electron volt when ultraviolet light of wavelength 100 nanometer is incident on it. A potential of 7.7 volt is required to stop the photoelectrons from reaching the collector plate. How much potential will be required to stop photoelectrons when light of wavelength 200 nanometer is incident on it? So that question is, silver has a work function of 4.7 electron volt. When ultraviolet light of wavelength 100 nanometer is incident on it, potential of 7.7 volt is required to stop the photoelectrons from reaching the collector plate. How much potential will be required to stop the photoelectrons when the light of wavelength 200 nanometer is incident on it? Okay, 15.4 volt, 2.35 volt, 3.85 volt, 1.5 volt. So your correct answer is option D is correct. But how? So we know the total energy is equal to kinetic energy plus work function. So that is, so total energy, this one HF, quantum mechanical energy HF, F is equal to C by lambda. So it's equal to EV. This one is the maximum kinetic energy. Okay, or stopping, and V is known as stopping potential. Okay, so plus work function. Similarly, second also wave, and another is SC by lambda prime. So EV prime plus omega work function. So now divided this by this. Okay, dividing. So this one is the equation number 2 and this one the equation number 1. Now dividing equation 2 by 1. So okay, 2 by 1. So we get equation, this one equation 2 and this one is the equation 1. So in case of lambda is equal to 100 nanometer first, and second wavelength is how much? Lambda is equal to 200 nanometer. So 100 by 200, that means 0 got 1 by 2. So EV prime plus W naught divided by EV naught plus W naught. Okay, now cross multiply with this here. This one is cross multiply, 2 times of this plus 2 times of this is equal to EV naught plus W naught. Okay, and so 2V naught, and this one is EV naught plus W naught, and this one change to on that side. So minus 2 W naught. So is equal to plus W naught minus 2 W naught is equal to minus W naught. So EV naught is equal to, now divided by 2 here. So EV naught is the value potential 7.7. Okay, and minus work function is 4.7. Here work function is 4.7. Work function is how much? 4.7. So we get EV naught is 1.5 electron volt. That means option D is correct. Okay.